Satellite imagery is a staple of weather world forecasting segments, but because of time constraints and the fact that some products aren't available right away, the imagery we typically show you only scratches the surface of what's actually available. This time of year, with the tropics heating up and thunderstorms still firing regularly over land, provides a great showcase for some of these products, most of which come from the two U.S. geostationary satellites parked over the equator and orbiting in sync with the Earth's rotation, so each satellite always has the same view. Combined, they monitor from the Western Pacific to Western Africa, scanning in 16 different channels or wavelengths, and routinely providing images every minute, as seen last Saturday when Hurricane Hannah came ashore in South Texas. This colorized infrared loop showing thunderstorms intensifying right up until landfall. This new generation of satellites also detects lightning, shown here as the blue pixels that come and go, depicting flashes per 5 minutes. Notice most of the lightning found on the periphery, little to none near the center. That's not uncommon because lightning typically requires very fast updrafts to separate electrical charge. But in the eye wall of a hurricane, air is spiraling quickly inward as it rises around the eye, so relatively speaking, the vertical movement isn't all that fast. But in contrast, thunderstorm systems over land typically have very rapidly rising air. Here's an example from the Northern Plains 2 weeks ago showing a huge cluster called a mesoscale convective system, or MCS. The core of this complex producing at times more than 50 flashes every 5 minutes. Satellites also provide some predictive capability by estimating severe weather potential ahead of the storm. This animation shows what we call CAPE, which stands for Convective Available Potential Energy, essentially thunderstorm fuel. Here, the increasing oranges and reds in the Dakotas, Minnesota, and Iowa provided clues to future development. The previous day, a different mesoscale convective system over Kansas and Oklahoma displayed what's called transverse banding, filaments of high-altitude ice clouds moving perpendicular to the motion of the system and away from its core. This region often houses turbulence, and the light blue numbers and symbols that come and go are pilot reports of turbulence, many near these transverse banding features. There's even a corresponding satellite-based turbulence probability product designed to diagnose turbulence and its potential at typical aircraft cruising altitudes between 30 and 40,000 feet. Let me finish by returning to the tropics and take a peek under the hood of Hurricane Douglas as it weakened northwest of the Hawaiian Islands earlier this week. This hybrid visible and infrared loop shows the low-level circulation of the storm emerging from beneath the higher and colder thunderstorm tops in green and blue. The separation of the low-level and high-level features caused by wind shear in this case signaled the demise of the storm. We are already up to the letter I in the Atlantic tropical season, and moisture from that storm may play a role in our extended forecast, which is next.